So one of the major problems that we're starting to run into with these AI agents like Claude Code or GPT is that the cost of using them do add up over time. Like they're not cheap, especially Opus 4.8. I think I've spent one prompt using like a dynamic workflow. I think I've used about $150 of API credits. Granted, I had the $100 a month subscription, so I didn't get charged that. But there is a lot of subsidies going on, and like when you interact with these models, they're using a lot of money that they're not actually charging you, right? But Headroom is supposed to be a tool that sits in between your agents or your harnesses like Claude Code to help cache and help optimize the output tokens that are coming back from the actual LLM providers and also what you're sending to them, right? So it can optimize a lot of things. And I want to kind of give you a demo of how this kind of works. So in a nutshell, you can get it installed basically by running these commands. You can then wrap your existing harnesses. So like if you're using Claude Code or Codex, you basically say headroom wrap Claude, which again, I'll just show you this live. I'll go over here and I'll wrap Claude Code in a new terminal instance. I'll run it. And then you will see it basically spin up Claude Code. You'll see that it's starting a headroom proxy at port 8787. And I don't know why it's taking so long to actually load up, but eventually Claude Code will load up. Okay, here it goes, which I can then interact with. So now every request I make to Claude Code, it's going to go through that headroom proxy, and it's going to try to compress some of the things that are happening. Like, for example, if you're sending in a bunch of logs, it'll find ways to compress it so you're not doing a bunch of additional wasteful token usage. Now, in terms of their proof of savings, this is their table that they give you. So code search, 100 results. Before it would take maybe 17,000 tokens. Now it's 1,400, which is a 92% of savings. SRE incident debugging, 65,000 goes down to 5, which is again a 92% savings. So there are savings that it says it provides. And I think it really depends on the workflows, especially if it comes to like if you were to take a huge debug log and paste it into your LLM provider, Headroom is going to compress that a lot because you'll notice there's a bunch of duplicate stuff that's always in your log. So it can find a way to compress that before it sends it over to the model. And also when the model gives back a response, it can compress it as well. I think another interesting place to look at is how compression works. Let me scroll down. There's another table that kind of gives you an idea. So if you're sending over JSON arrays, the typical savings is like 70 to 90% using a smart cruncher compressor. So they have all these different compressors that are built into Headroom to help determine what exactly you're sending to the model and how it could basically use that compression algorithm to reduce the amount of tokens that are sent in. So from the looks of it, it looks pretty nice. I mean, like it's saying huge savings on all this different stuff. Now I mentioned how the Headroom proxy works, and you should probably understand what a proxy is. But basically, if you're running Claude Code, it actually is going to make a request to the Headroom proxy, and the Headroom proxy is going to make a request to Anthropic, the LM provider, right? So Anthropic like this, so that when it sends stuff in and when stuff comes back, it'll be compressed. Now, the cool thing about this is that it actually sits in front of all of your harnesses. So if you're using something like Cursor CLI or using something like Codex, technically they're all hitting the same Headroom proxy if you have it configured. So you're actually going to start getting some shared compression for everything. It's all hitting the same proxy. It all eventually starts to learn how to better optimize your code. And I'm guessing if you run it for a while, you will get some better compression rates, as they kind of mentioned in their docs. Now to kind of show you, I did run Headroom Perf, which kind of gives you a breakdown of the savings. I've used this for about 52 million tokens using Claude Code. And overall, my savings were about 13%. Okay, so I did 311 requests. The overall token usage for Opus was, I think, around 50 million, right? So overall, $9 for the short session that I ran, 13%. This could add up. So if you want to try to reduce the amount of things that you're spending in terms of token usage, maybe installing this could be kind of useful. It also gives you a performance breakdown of like your cache hit rate. So you'll see here we have like a pretty decent amount of cache hit rates here. Optimization overhead. So the average request took an extra 754 milliseconds to optimize the queries. But there's also a max here of 30 seconds. So I don't know, some of my requests might have basically locked out or blocked out. Not sure why I said 30 seconds there. I think the last thing that's worth mentioning here is this Headroom learn command. So basically, as you're using Headroom, it's kind of learning where the LLM screws stuff up on. Over here, it's saying that it has a bunch of different calls, a ton of failures, and it's kind of documenting, for example, never use Bear, Python, pip, or rough. So I'm guessing as you're using Headroom, it's trying to figure out, okay, the LLM basically keeps running into errors because it made false assumptions, and Headroom learn is a way to basically store those failures so that it can stop making those mistakes in the future. And then, of course, save you on token usage. I could try to do headroom learn over here. I haven't actually ran it yet, but let's run it. But as it mentioned, it should go through all of the request history of your project. So for example, I'm running this in the mission control project. So I'm guessing it's mining all of the failed Claude sessions and trying to build up a good breakdown of like where stuff goes wrong when I'm trying to prompt with Claude Code. All right, so after running headroom learn, it came back with over 389 failures that it found out of 7,000 calls to Claude Code. And the recommendations it came back with were 6. And you'll see these 6 recommendations are all here. Now, I'm not really sure how I understand reading this. So basically it's saying that if you put this in your Claude MD file, you may get 18,000 tokens saved. I don't know if that's like per request, but it's just information about these files are large and were repeated, reread in full. Use offset limit or grep instead. So it's telling the LLM, hey, when you're going to read any of these files, make sure you do like a proper offset or grep, because I mean, it just kind of fills up your context window. And so in the future, it's going to reduce how much tokens you're using if you ever have to hit those files again. Here's another instance, project layout, server controllers. I guess just telling Claude Code, this is like the layout of stuff, can help potentially reduce on token usage because they don't have to keep on going and traversing your code base. Build and verify commands. I guess this is something else that it kept on trying to go and look up. Package manager is PNPM. Type check with PNPM type check. So my assumption is that with the headroom learn, it found that it tried to call commands that this project never even uses. And then it had to go back and recorrect itself and run the proper commands. And then it, without having to do that over and over again, you're going to end up getting tokens saved. Now it also recommends what it could write to your Claude memory file. So you see here it says memory/memory MD. Here are all the things that I basically made pivots to on my project. So at some point I changed it from automaker to mission control sessions. I also changed it from being free to a pro license, etc. And just having this information mapped out in memory can help the agent not accidentally make false assumptions of your code base and then waste a bunch of time going through and realizing, oh, that's been completely changed based on some false information that I had, okay? But yeah, overall, I mean, if you go and read through this, it says when to use. It's a great fit if you run AI coding agents daily and want savings without changing your code, okay? And I do think that 14% savings for me using it is enough for me to actually want to start using this. I think it's a pretty cool tool. Work across multiple agents and want shared memory. Again, I do this all the time. I use Claude Code, I use Codex, I use Cursor. I'm kicking off various different things depending on the task at hand. And so having a shared proxy to kind of compress and optimize my token usage, I think is a good idea. Need reversible compression. Originals are retrievable by CCR, which I don't know what this is, honestly, so I'm going to skip it. Skip if you only use a single provider native compaction and don't need cross-agent memory. So again, if you're just using Claude Code and that's the only tool you ever use, Claude Code has compression built into it, right? It also has memory built into it. So do you need a shared memory? Probably not, right? But for me, I do switch between these different tools, and I do think it is kind of useful. Work in a sandbox environment where local processes can't run. So again, there's no reason to have this. If you're going to spin up a sandbox that runs in isolation and it gets torn down, is it useful having headroom live there? Probably not, because the savings are not going to add up over time. Where you get the savings from what I understand, is having this run for a long time and it slowly starts to learn your code base and where it can optimize and save on tokens. All right. Anyway, hope you guys enjoy. Go check out headroom. I'll try to use it for a longer period. I'll probably use it for like a week or two and come back and make another video to see how much I've saved. But it seems like a pretty popular repository, so go check it out. Have a good day and happy coding.